Here is an interesting question for you. We have 3 distinct cylinders, one pink, one blue, and one yellow. Along with them, we have 5 identical white marbles. How many ways can we distribute these marbles into the cylinders? It is perfectly fine if some cylinders stay empty and the arrangement of the cylinders is fixed. How would you find the answer? What if there were 5 distinct cylinders and 12 identical marbles? How would you find the answer then? If you want to try solving these 2 problems on your own, pause the video for a moment. I'll be back soon. Okay, let's dive into the solution. There are actually 2 ways to solve this problem, and I will start with the first method to build our intuition. The first method is to count every single possibility very carefully. We can divide the scenarios based on how many cylinders we actually use. The first case is using only one cylinder. We can put all 5 marbles into the pink, the blue, or the yellow cylinder. That gives us 3 obvious ways. The second case is using exactly 2 cylinders. This means we need to divide 5 marbles into 2 groups while one cylinder stays empty. There are 2 main patterns here, the 4-1-0 split and 3-2-0 split. The first pattern here is the 4-1-0 split. Since all cylinders are different and all the marbles are same, we are looking at the arrangements of the numbers 4, 1, and 0. That is 3 factorial, which equals 6 cases. The second pattern is the 3-2-0 split. Again, this is an arrangement of 3 distinct numbers, which gives us another 3 factorial, or 6 more cases. So, for the 2-cylinder scenario, we have a total of 12 cases. Finally, the third case is using all 3 cylinders. We have 2 patterns here as well, the 3-1-1 split and 2-2-1 split. The first pattern here is the 3-1-1 split. To calculate this, we simply choose which cylinder gets the 3 marbles. There are 3 choices. So, the 3-1-1 split pattern has 3 cases like this. The second pattern is the 2-2-1 split. Similarly, we choose which cylinder gets the single marble, giving us another 3 choices. So, for the 3-cylinder scenario, we have 6 cases in total. Now, let's add them all up. 3 cases from the first scenario, plus 12 cases from the second, plus 6 cases from the third. 3 plus 12 plus 6 is 21. 21 is our final answer. But wait! What if the numbers were much larger, like our second question? Counting one by one would be an absolute nightmare. This is where the second method comes in, and it is honestly a game changer. For this method, we are going to use a special trick. We are going to bring in 2 sticks. Why 2 sticks? You will see why in just a moment. But now, imagine arranging these 5 marbles and 2 sticks in a single row. The sticks act as dividers that separate the marbles into 3 groups. The marbles to the left of the first stick go into the pink cylinder. The marbles between the 2 sticks go into the blue cylinder. And the marbles to the right of the second stick go into the yellow cylinder. If the 2 sticks are right next to each other, it just means the corresponding cylinder is empty. If a stick is at the very end, it means the cylinder on that end is empty. Every possible arrangement of these 7 items corresponds to exactly 1 way to fill our cylinders. So, the problem transforms into a simple permutation. We have 7 total positions to fill, with 5 identical marbles and 2 identical sticks. The formula is 7 factorial divided by 5 factorial and 2 factorial. When you calculate that, the answer is 21. See how much faster that was? This method allows us to solve much more complex problems effortlessly, such as our second problem. Here, we have 5 distinct cylinders and 12 identical marbles. In this case, we need to divide the marbles into 5 sections, so we need 4 sticks. Now, we just calculate the number of arrangements of 12 marbles and 4 sticks. That would be 16 factorial divided by 12 factorial and 4 factorial, which equals 1,820. How exciting! If you enjoyed this video, make sure to stay tuned. I will be back with many more fun problems soon. Thanks for watching.